All right, day 59. We're dealing with the boats to save people problem. And the statement says a big ship has with numerous passengers is sinking, and there is a need to evacuate these people with a minimum number of life-saving boats. Titanic vibes. Each boat can carry at most 2 persons. However, the weight of the person or the people cannot exceed the carrying weight limit of the boat. We have an array of people where people at index I is the weight of the ith person, and an infinite number of boats where each boat can carry a maximum weight called limit. Okay, and it also carries at most 2 people at a time. So, and it's provided that the sum of the weight of these people is under or equal to the weight limit. Let's look at the example very quickly. So we have this array of people, and the numbers there represent their weights, and the boat has a limit of 3. So you can take at most 2 individuals, but their weights must not exceed 3 as a total. And so if we put the person that weighs 2 in the boat, we notice that, okay, the limit is 3, so we can still add 1 more person. And once you do that, you've reached the limits of the boats, and you need a new boat to get that other person, as you can see here. 1, 2, then 1, like so. So you need 2 boats at minimum. Yeah. There's no other way to do it, because I mean, you can put 2 in the person that weighs 2 in a single boat on his own, and put the 2 ones on their own boat, and you still have that find that you need 2 boats. So it's not too bad a problem. Let us find out how to solve it. Now the naive solution is put in a nested loop, and for each person check all the remaining people to see if they can form a pair that fits into a boat. Okay, this is like a recursive, super naive thing. We don't need that. We're looking for the optimized solution with a greedy pattern. Okay. All right, let's step through the code solution. These are the steps. As you can see, even with the diagram. And this is the code that implements those steps. Okay, now follow me closely. So we sort the people array in ascending order, so that the lightest person is at the start of the array and the heaviest person at the end of the array. Okay, that's what we're doing here. We sort them by weight, like so. So this becomes sorted. The people here become sorted. And then we initialize 2 pointers, left and right. The left pointer points to the lightest person at the start of the array, and the right pointer points to the heaviest person at the end of the array. As you can see here, start off at index 0, and then start off at the last value, right? Left and right. The left pointer points, okay. Next, the variable boats is initialized to 0, representing the number of boats used, as you can see here, what we're gonna work with. Now iterate over the people array until the left pointer is greater than the right pointer. This means that all the people have been rescued. Perform the following steps in each iteration, and that's what this looks like. While the left is less than or equal to the right, do this. Check if the lightest and heaviest persons can fit in one boat, that is people plus people on the left, person on the left, and person on the right, is less than or equal to limit. If they can fit, the left pointer is incremented and the right pointer is decremented. And we see that here. So if people left plus people right is less than or equal to the limit, they can fit. So we'll move on to the next lightest person, because that first person at that position is rescued. Pretty much this current position is rescued. So increment left and decrement right either way. And if they cannot fit in the boat, right, the heaviest person is rescued alone, and the right pointer alone is decremented. So either way, the right pointer is going to be decremented, as you can see here. It's not decremented in here, just in case it's not, so you don't have to do it twice, basically. So this only happens here, and then the boat's variable is incremented by 1, regardless, because someone just got saved. As you can see right here, and then you keep doing that until the very end. And afterwards, you just return boats. C'est fini. Pretty cool. So, and then there's this diagram that shows it. So yeah, we have this with a limit of 5. So first of all, sort it, right? That's what this does. First of all, you sort. Then have left and right, as you can see here. Left and right. And then if it's less than or equal to the limit, since it's bigger than the limit, because left by right is 6 and the limit is 5, it's bigger than the limit. So we take only, so now we're in this loop actually. It's bigger than this in this case, so this doesn't trigger. But so we just take the first right person, this goes away, and then the right pointer moves over here. That's what would happen. Okay, and that's it. So now 4 plus 1 is gonna work, right? And then you just keep looping through that, and you're done. It works. For the 2 of them get rescued, the 2 of them get rescued again. Then now left and right are the same, and the diagram has an issue, but it's the very last one. Left and right are the same, so whether any of these happen doesn't really matter, because it's not going to happen again, but this is going to get incremented though, so it works. Turns out okay. All right, we're done with that. Let's look at the time complexity real quick. N log of n for sorting, because that's the best you can get with sorting algorithms if you're familiar with them. And this sorting algorithm takes O of n space to store the people array. Therefore, the space complexity of the solution above is O of n. And that's all for this problem. See you next time.